In this lesson, we're going to look at multiplying rational expressions. And so this time, your rational expressions are not necessarily monomial factors. See how this is a monomial factors? All the rest are not monomial factors. In the previous lesson, if you go back to that previous lesson that we did, we had that same idea. See, multiply rational expressions, same directions, except this time, in that lesson, all your factors were monomial factors. Now, make sure you go back to our previous topic, where we had a few lessons where we simplified rational expressions. So just go back and make sure you understand how to simplify rational expressions. Okay? And there were 3 lessons dealing with that. And also make sure in that same topic that you review the idea of opposites. All right, so because all of this is going to be needed, all of this will be needed with our examples that we do here. Okay. All right. So let's look at that first one. So again, you want to multiply those 2 rational expressions, and then you want to simplify. Okay. Okay, so the first step you're going to do, just like you did in previous lessons, is you're going to factor. So your steps. So remember your steps. So the number 1, you're going to factor all numerators and denominators. Okay? So basically you're going to factor your polynomials. That's what you're going to do. So if you look at, and I'm going to go ahead and do the steps here. So if you look at that first numerator, that's the linear factor, and the GCF is 1. So there's nothing I can do with that one, so I'm just going to go ahead and rewrite it. The denominators are monomial factors, so I'm going to just rewrite all monomial factors. Now, in the second rational expression, the numerator, it looks like I can factor out an x. So I get times x minus 3, right? Okay. The denominator, I'm going to go ahead and factor that as 2 binomials. So it looks like we can get x times x, and that's going to be 5 and 3. And it looks like the 5 will be positive and the 3 will be negative. Okay? Now at that point, so remember we did step 1. So step 1 we factored. Now just as before, step 2 is you're going to reduce common factors. Okay? So reduce common factors. So if we look at the first factor, x plus 5, is there a factor of x plus 5 in the denominator? Yep, right here. So remember when you do reduce that, you're left with factors of 1. Okay, so don't forget to do that. Then the next factor is an x. Is there an x occurring as a factor in the denominator? Yep, right here. So that will divide out, and you're left with factors of 1. The next factor is x minus 3, right? So those divide out, so you're left with factors of 1. And so look at what you have. You have 1 times 1 times 1, which is 1. 1, and now the denominators. 1 times 1 times 1, which is 1. And so you get the answer of 1. All right, so remember the first step you had to do was you factor all the numerators and denominators. Then you reduce your common factors. And then step 3, once you do that, step 3 would be to write your final answer. Write your final answer as a rational expression made up of the factors. Okay, so you wrote this as one rational expression. All right, so let's look at number 2. Number 2, you have y squared minus 9 divided by y squared times, and then the second rational expression, you have y squared minus 3y divided by y squared plus 3y minus 18. Okay? All right, so again, the first thing you're going to do is you're going to factor all polynomials. So the first factor here, the numerator here, that's the difference of 2 squares. So I can factor that as y minus 3 times y plus 3 divided by, the denominator is a monomial factor, so I'm going to leave that alone. Over here, it looks like, again, I can factor out a 3, so I get, a y. So I get y times y minus 3, right? Divided by. Over here, if I factor 2 binomials, I'm going to get y. Looks like it's going to be, what, 6 and 3? So 6, 3. 6 is positive, 3 is negative. And so it looks like I factored. All right, so step 2 then is to reduce. So look at your first factor, y minus 3. Will that reduce with a factor y minus 3 down there? Yep, right here. So those divide out, so those reduce, and you're left with factors of 1 in their place. The next factor is y plus 3. Do you have a y plus 3 occurring down in the denominator? Nope. The next factor is a y. Do you have a factor y in the denominator? Yeah, I have 2 of them. All right, so just be a little bit careful. So remember, y divided by y is 1, and you're reducing it with one of these, so that'll be just one factor y left. The next factor is y minus 3. Do you have a y minus 3 in the denominator? No. So you're done. So you just got to now just write it as one rational expression. So you just write it as a product of factors as one rational expression. So don't leave it like this. So you're going to say 1 times y plus 3 times 1 times y minus 3 is y plus 3 times y minus 3. The denominator, y times y plus 6 times 1 is y times y plus 6. And so there's your answer. So leave your answer in factored form. Don't multiply this out. Don't multiply this out. Leave it in factored form. That's your answer. Okay? Because at some point later on in the next course, and when you start dealing with graphing rational functions, it'll be important if you leave those in factored form. So just leave it in factored form. All right, number 3, we have 36x squared divided by 5x squared minus 40x plus 80. So we have that rational expression being multiplied by this rational expression, 5x minus 20 divided by 6x. Okay? All right, so remember the first step is to factor. So the first numerator, those are monomial factors. I'm not going to deal with that just yet. So I'm just going to rewrite it as 36x squared divided by. Now in this denominator, and I'm going to go off to the side right here and do that because I'm going to factor out a 5 first. So let me go ahead and do that here. Because you know the GCF here is 5. So I get 5 times x squared minus 8x plus 10, right? And then you got to make sure you see if you can factor this trinomial. So I get 5 times, and that's going to be x, let's see, that's going to be, and I think I may have left something off here. Let me make sure that's correct. All right, so that's not a 10, that's 5 times 16, right? All right, so 16. All right, so I'm going to get, let's see, this was that 4 and 4? Okay, so x minus 4 times x minus 4, right? Okay, so that's going to go here. So I get 5 times x minus 4 times x minus 4. All right, the next one, the next rational expression, the numerator, I can factor out a 5. So I get 5 times x minus 4. And the denominator is a monomial factor. Just go ahead and rewrite it. Okay, so I factored all my polynomials. The next step is to reduce. So look at your first factor, 36. Will 36 reduce with any of these factors that are in the denominators? So see your factors are 5, x minus 4, 6, and x. Yeah, with the 6, right? So 6 into 6 is 1, 6 and 36 is 6. Okay, the next factor is x squared. I have 2 of them. Do I have any factors of x in the denominator? Yep, right here. So I have 1 down here, 2 up here. So that will divide out, and you're left with 1x to the first, one factor of x. The next factor is 5. Will 5 reduce with any factor down there? Yep, with this one. So 5 and 5 is 1, 5 and 5 is 1. The next factor is x minus 4. Will that reduce with any of the factors down there? Yep. In fact, there are 2 of them, but we can only use 1. So that's 1, and that's 1. You're left with factors of 1. And so therefore that takes care of everything. So now you're going to write your final answer as one rational expression, and it's going to be the product of all these factors. 6 times x times 1 is 6x. And then 1 times x minus 4 times 1 times 1 times 1 is x minus 4. And so there's your answer. All right, so that's number 3. Okay, number 4. So again, in order to do those, you need to remember how to simplify rational expressions. That's really what you're doing for the most part. Okay, number 4, we have this. Number 4, we have t to the 4th minus 81 divided by t to the 4th minus 16 times t squared plus 4 divided by t squared plus 9. Okay? All right, so we have this rational expression being multiplied by this rational expression. The first thing you want to do is you want to factor all of your numerators and factor all of your denominators. So you're going to factor all of your polynomials. So if you look at that first one, that's the difference of two squares. So if you think about it, I can factor t to the 4th minus 81 as t squared minus 9 times t squared plus 9, right? And then the denominator, and by the way, I can go further with this one, but I'm going to leave it alone for right now. And then the denominator, that's going to be t squared minus 4 times t squared plus 4. Y'all agree? Times, over here, you see that's the sum of two squares, isn't it? So I cannot factor the sum of two squares. So all I can do is just rewrite it. T squared plus 4. And this is also the sum of two squares. So I cannot factor the sum of two squares. And so if you look at this, now really let's go ahead and factor t squared minus 9. So that would be what? T minus 3, t plus 3 times t squared plus 9 divided by, and then I can do the same thing here. That's going to be t minus 2 times t plus 2. T minus 2, t plus 2 times t squared plus 4. So all I did was I just went ahead and factored the difference of two squares. And then again, I cannot do anything with the sum of two squares. So I'm just going to rewrite this over. Now once you factor, the next step is to simplify. So my first factor is a t minus 3. Is there a t minus 3 occurring as a factor in the denominator? No. My next factor is t plus 3. Is there a t plus 3 in the denominator? Nope. The next factor is a t squared plus 9. Is there a t squared plus 9 in the denominator? Yep, right here. So those divide out. You'll have factors of 1. The next factor is a t squared plus 4. Is there a t squared plus 4 occurring in the denominator? Yep, right here. So those divide out. You'll have factors of 1. And so your answer is going to be t minus 3 times t plus 3 times 1, which is t minus 3 times t plus 3, divided by the denominator, t minus 2 times t plus 2 times 1 is t minus 2 times t plus 2. And there's your answer. So again, leave your answer in factored form. Don't multiply this out. If you multiply it out and you made an error, you're going to not get full credit. So leave it in factored form. That's going to be important later on anyway. All right, number 5. Number 5, we have x plus 5 cubed divided by x plus 3 cubed times, and then on this rational expression, I have x squared, that's an x, plus 6x plus 9 divided by x squared plus 10x plus 25. Okay? All right, so the first step again is to factor. Now notice that this numerator and this denominator is already, it's already listed as a product of factors. So x plus 5 to the third power, x plus 3 to the third power. So I'm just going to go ahead and rewrite this over. So I get x plus 5 to the third. And in the denominator, I get x plus 3 to the third. All right, now over here, I can factor this. See, that's a perfect square trinomial. I can factor that as x plus 3 times x plus 3, right? Or I can write as x plus 3 squared. Does not matter. Over here, and then the denominator, that's also a perfect square trinomial. So I can write it as x plus 5 times x plus 5, right? Okay. Now, some students, they prefer to leave it like this. Other students may want to write it as x plus 3 to the second power. It does not matter. Does not matter. All right. Now, here's what I want you to think about. So I factored, everything's factored now. So let's look at your first factor. You have an x plus 5. In fact, there are 3 of those. Do you have any factors of x plus 5 in the denominator? Yeah, you have 2 of them, right? So two of those will reduce into one into those 3 here, and you're left with only 1. So you're left with 1 factor of x plus 5. And it kind of makes sense because if you think about it, I want you to think about this, okay? I want you to think about this. So let's think. So remember, x plus 5 to the third means x plus 5 times x plus 5 times x plus 5, right? And the denominator, you have x plus 5 times x plus 5. And I'm not going to worry about writing everything else. I just want you to think about what's happening here. So these x plus 5s divide out. These x plus 5s divide out. And what are you left with? 1 factor of x plus 5, which is what this is. Okay? All right, so that was that part so far. So let's see. Then the next factor is x plus 3. In fact, I have 3 down here, 3 factors in the denominator. How many factors of x plus 3 do you have in the numerator? 2. So all of those will divide out into 2 of these, and you're left with 1. And so it looks like the answer is going to be x plus 5 times 1, which is x plus 5, divided by x plus 3 times 1, which is x plus 3. All right, so that was number 5. Okay, number 6, we have this. All right, number 6, we have 3x squared minus 48 divided by 9x squared minus 81 times, that's going to be, the next one is 18x plus 48 divided by 6x minus 24, okay? All right, so if you look at that first, again, the first thing you're going to do is you're going to factor your polynomials. So if you look at that first one, I'm going to go ahead and do that on the side. So let's look at that first numerator, 3x squared minus 48. So if I look at that, I can factor out a 3, couldn't I? So that'll be 3 times x squared minus, and then that looks like that's going to be what, 16? And then I can factor that further, so that'll be 3 times, because that's the difference of 2 squares, so that's x minus 4 times x plus 4. So that's going to be the numerator. So the numerator is this right here. So the numerator is 3 times x minus 4 times x plus 4. The denominator, and let's think about that. So the denominator is 9x squared minus 81. So I can factor out a 9, and when I do that, I get x squared minus 9, right? And so I can factor this, because that's the difference of 2 squares. So I get 9 times x minus 3 times x plus 3. So that is going to go in the denominator. So 9 times x minus 3 times x plus 3. In the numerator, now I don't need to do any work for the numerator here because that's easy to deal with. So if I look at the numerator, it looks like I can factor out an 18. So I get 18 times x plus 3. The denominator, the GCF is 6. I can factor out a 6. I get 6 times x minus 4. All right, so I factored all the polynomials. Now I'm going to reduce. My first factor I see is a 3. Will 3 reduce with any factor in the denominator? Yeah, in fact, 2 of them. Either this one or that one. Doesn't matter which one I use. Let's just use this one. So 3 to 3 is 1. 3 to 9 is 3, right? Okay. The next factor is x minus 4. Do I have a factor of x minus 4 in the denominator? Yep, right here. So those will divide out. So you get factors of 1. The next factor is x plus 4. Do you see an x plus 4 in the denominator? No. The next factor is 18. Will 18 reduce with any of these down here? Yeah, in fact, both of them. So let's think about this. 3 to 3 is 1. 3 to 18 is 6, right? 6 and 6 is 1. 6 and 6 is 1. The next factor is x plus 3. Is there an x plus 3 occurring as a factor in the denominator? Yep, right here. So those divide out, and that's it. So the answer is going to be 1 times x plus 4 times 1 times x plus 3, times 1, which is x plus 4. The denominator, 1 times x minus 3 times 1 times 1 times 1 is x minus 3. So there's your answer. There's your answer for number 6. Okay, number 7. Number 7, we have, all right, so let's see, we have k squared plus 9k plus 20 divided by k squared plus 10k plus 24 times k squared plus 6k divided by k squared plus 10k plus 25. Okay? All right, so I have those two rational expressions that I'm multiplying together. And so the first thing you want to do is you want to factor all of your polynomials. So if I look at that first numerator, it looks like I can factor that as, let's see, what's that? That's going to be k, 5 and 4. So plus 5 plus 4. All right, so that looks like that's going to work. Then the denominator, that's going to be, let's see, k plus 6, k plus 4. Okay? Now let's go to the next rational expression. The numerator looks like I can factor out a k. So when I factor out a k, I get k times k plus 6. The denominator looks like that's a perfect square trinomial, so it'll be k plus 5 times itself, right? Okay, so that is going to give me this. All right, now once I factor, remember once you factor, you reduce. So my first factor is k plus 5. Is there a k plus 5 occurring down here as a factor? Yeah, in fact, there's two of them, but there's only one factor up here, so you can only use one factor down there. So let's just do the first one. So k plus 5 divided by k plus 5 is 1. The next factor is k plus 4. Is there a k plus 4 occurring down here? Yeah, right here. So those divide out. Make sure you understand that you got to put factors of 1s here. The next factor is a k. Is that a k occurring as a factor in the denominator? No. The next factor is a k plus 6. Is there a k plus 6 occurring as a factor? Yep, right here. So those divide out, and then that's it. So you get 1 times k times 1, which is k. The denominator, 1 times 1 times 1 times k plus 5 is k plus 5. And so there's your answer. That's all you do. So it's not that bad. Just you have enough experience with quite a few problems from the previous topic, so that's supposed to help you with this. Okay, number 8, we have x squared divided by, so x squared divided by 4x squared minus 9. So that rational expression is being multiplied by this one, and that is 2x squared minus 13x plus 15 divided by x squared minus 5x. All right, so let's look at factoring. So the first numerator, those are monomial factors. So I'm just going to go ahead and just rewrite it. The denominator looks like that's the difference of two squares. So I'm going to get 2x minus 3 times 2x plus 3. All right, so the next rational expression. The numerator here looks like I can factor that as 2x, and then 5 and 3. So it looks like 5 is going to go here, 3 is going to go here. Yep, and then minus, minus. And then the denominator looks like I can factor out an x. I get x times x minus 5. Okay, so once you factor, the next step is to reduce. So let's look at the first factor. Okay, so I have two factors of x. Do I have any factors of x in the denominator? Yeah, just one of them though, right here. So x divided by x is 1, so that's going to reduce with one of these, so they'll be left with one factor of x. The next factor is 2x minus 3. Is there a factor of 2x minus 3 occurring in the denominator? Yep, right here. So those will divide out. You get factors of 1. The next factor is x minus 5. Would that divide out with one of these down here? Yep, right here. So that'll be factors of 1, and that's it. So you get x times 1 is x. And over here you get 1 times 2x plus 3 times 1 is 2x plus 3. And so there's your answer. Okay, number 9. Number 9, we have 4x minus 7 divided by 4x plus 7, right? So 4x minus 7 divided by 4x plus 7 times x minus 6 divided by 6 minus 6. Okay, now, so remember in the previous topic we talked about opposites? All right, so that's going to be needed in this one. So if you look at all of your numerators and denominators, they're all linear factors and the GCF in each one is 1. But I do know this. I know that x minus 6 and 6 minus 6 are opposites. Remember the idea of opposites? So that means that when I divide those in terms of opposites, one factor is going to be a negative one, a positive one, and the other is going to be a negative one. And we always tend to put the negative one in the numerator. And so therefore the answer is going to be, and remember, you always write it as factors. And so the answer is going to be negative 1 times, just like this, negative 1 times 4x minus 7 divided by, and then 1 times 4x plus 7 is 4x plus 7. And so there's your answer. And just leave it in factored form. Now, if you were to distribute that negative 1, there's nothing wrong with that. We just tend to prefer to write things in factored form. So you could write it as negative 4x plus 7 divided by 4x plus 7. Now be careful, don't think those are the same because they're not the same. See, that's a negative 4x, that's a positive 4x. All right, so either one of those is fine. All right, number 10. So number 10, we have 5x squared minus 7x minus 6 divided by, and then that is 3x squared plus 11x plus 6. So we have this rational expression being multiplied by this rational expression, and that is x squared plus 3x minus 10 divided by 5x squared minus 7x minus 6. All right, so we're going to multiply those two rational expressions. Now again, the first thing you got to do is factor. That's the first step, is to factor. So if you look at that first numerator, the polynomial that's in that numerator, it looks like I can factor that as 5x, x, and then 3 and 2. So it'll be plus 3 minus 2. So let's see if that works. Yep, okay, so those are two factors of this polynomial. The denominator looks like that's going to be x plus 3, 3x plus 2. So let's see, that's 9x, and yep, so you get 11x. All right, the next one, the next rational expression, the numerator here, that looks like that's going to be xx, 2 and 5, and looks like 2 is negative and 5 is positive. The denominator, I can factor that as 5x, x, so that looks like 5x plus 3, x minus 2. Let's see if that's going to work. Yep. All right, so I factored all the polynomials. Now remember, the next step is to reduce. So you see, it's not that bad. As long as you know how to factor, and as long as you know how to simplify, you're done. You know how to approach this. So we have 5x plus 3 occurs as a factor. Do I have a 5x plus 3 occurring down here? Yep, right here. So those divide out. Make sure you put ones in their place. X minus 2 and then x minus 2, so those divide out. X minus 2, I don't have an x minus 2 anymore. So I can't reduce this with any factor in the denominator. X plus 5, I don't see an x plus 5 down here. So therefore the answer is going to be 1 times x minus 2 times x plus 5. So that's x minus 2 times x plus 5. The denominator looks like that's going to be x plus 3 times 3x plus 2 times 1 times 1. So x plus 3 times 3x plus 2. Okay? Again, don't multiply this out. Leave it in factored form. Leave in factored form. Okay? All right, so don't multiply it out. Okay, number 11. So let's look at number 11. Number 11, we have x plus 13 divided by, so x plus 13 divided by x minus 9 times, and then that's x cubed minus 729 divided by x squared plus 9x plus 81. Okay? All right, so these are linear factors right here, and then the GCF is 1, so I cannot factor these two. Here it looks like this is the difference of two cubes. So let's go off to the side and make sure that's correct. So we got to fill in these parentheses. If this is the difference of two cubes, then I can fill this in. So this term here, x cubed, that becomes x to the third power. 729, if you can't figure it out, then just use your calculator. And I can't seem to find my calculator, but it looks like that's going to be 9 cubed. 9 times 9 is 81. 81 times 9. Yep, looks like that's correct. So therefore, you remember when you factor the difference of two cubes, you get a binomial times a trinomial, and this trinomial you cannot factor. So the binomial is x minus 9. And then a trinomial is where you take that x here and you square it. Then remember it's plus the product of the x and the 9. So plus 9x. And then plus the last squared. So 9 times 9 is 81. So that's the numerator. So I'm going to get x plus 13 divided by x minus 9 times this right here, x minus 9 times x squared plus 9x plus 81 divided by x squared plus 9x plus 81. Because if you try factoring this, you can't. In fact, you cannot, because isn't this, and then you got that from here. And remember, when you factor the difference of sum of two cubes, you get a binomial times a trinomial. That trinomial cannot be factored. All right, so I factored all of my polynomials. So now let's go ahead and reduce. I have an x plus 13. Do I have an x plus 13 occurring down here? No. I have an x minus 9. Do I have an x minus 9 occurring down here? Yep. So those divide out. And you see this trinomial, see this factor divides out with this factor. And so therefore you get x plus 13 times 1, which is x plus 13, divided by 1 times 1, which is 1. But again, don't leave it like that, because you know that x plus 13 divided by 1 is just x plus 13. Okay? All right, let's do one more. So this is going to be number 12. Number 12. We have r squared plus 9r plus 18 divided by r squared plus 11r plus 30 times, and then this one's going to be r squared minus 2r minus 35 divided by, and that's r squared minus 13r plus 42. Okay. So again, if you want to multiply two rational expressions, the first thing you need to do is factor. Okay, that's how, because you got to simplify. So to simplify, you're gonna reduce factors. So you got to factor first. So when I factor the numerator here, it looks like I'm going to get r plus 6 times r plus 3. Okay, so that gives us this. The denominator looks like that's going to be r plus 6 times r plus 5. Okay, and the numerator over here, that looks like that's going to be r plus 5 times r minus 7. Yeah, that's correct. And then the denominator, that looks like that's going to be r minus 6 times r minus 7. Okay? All right, now once you factor, remember the next step is to reduce. So look at each factor in the numerators. The first factor I see is r plus 6. Well, r plus 6 occurs as a factor down there. Yep, right here. So those divide out, just like that. The next factor is r plus 3. Well, is there a factor of r plus 3 in the denominator? Nope. The next factor is r plus 5. Is there an r plus 5 in the denominator? Yeah, right here. So those divide out. The next factor is r minus 7. Is there an r minus 7 in the denominator? Yep, right here. So those divide out. And that's it. So therefore, you're going to get 1 times r plus 3 times 1, which is r plus 3, right? The denominator, 1 times r minus 6 times 1 is r minus 6. And that's it. So that is number 12. Okay, so that's going to take care of this lesson dealing with multiplying rational expressions and then simplifying.